All right, ready to dive into a mystery that's both terrifying and scientifically intriguing?
Oh, I'm ready. Lay it on me.
Spontaneous human combustion. You know, the idea of a person suddenly bursting into flame.
Well, no, and no apparent cause.
Right.
Yeah.
It's been captivating imaginations for centuries, appearing everywhere.
Everywhere.
From Charles Dickens novels to the X-Files even.
Right.
And today we're going to deep dive into 5 fascinating factoids.
Right.
To see if there's any scientific basis for this phenomenon.
Oh, okay.
Or if it's just a fiery myth.
Right.
And since this is cocktail party chemistry,
of course,
we're going beyond the sensationalism to explore the chemistry behind the claims.
The actual science. I like it.
Exactly.
Yeah, it's definitely a topic that sparks curiosity.
It does.
But let's start by addressing the elephant in the room.
Okay.
The prevailing scientific view is that full-body, spontaneous human combustion,
right,
like as dramatically depicted in fiction, is highly unlikely.
Okay.
There's simply no known chemical process within the human body that could generate enough heat to cause that kind of complete and sudden combustion.
So no Human Torches walking around then?
Probably not, no.
That's a relief, I guess.
Yeah.
But I've read about cases where people have burned to death without an obvious external source of ignition. How do scientists explain those?
Those cases are definitely intriguing.
Right.
And while they don't involve like a sudden burst of flames, they often involve smoldering clothing and nearby flammable materials.
Okay.
This suggests a slower smoldering fire rather than a spontaneous inferno.
Gotcha.
And this leads us to our first factoid.
Right.
Can the human body actually act as fuel for a fire?
Okay.
Even if it can't spontaneously ignite? And the answer, surprisingly, is yes, to some extent.
Okay, now things are getting interesting. So, how can a human body act as fuel?
Good question.
We're not exactly walking bundles of kindling.
You're right. The human body is mostly water.
Sure.
But we also contain flammable substances, particularly fat.
Okay.
And as you probably remember from high school chemistry, fat is a hydrocarbon.
Right. Hydrocarbons are those molecules made of hydrogen and carbon atoms.
Yeah.
And if memory serves, hydrocarbons are highly flammable.
Exactly. Think of a candle.
Okay.
The wax, the hydrocarbon, burns slowly, drawing fuel from the wick. So you're saying that body fat could be the fuel source in these mysterious fire cases.
It's possible.
Yeah.
But what acts as the wick?
That's where the wick effect comes into play. Our second factoid for today.
Right.
It's a theory that attempts to explain how a fire on a human body could be sustained.
Okay.
The idea is that when a body burns, the intense heat melts body fat, which can then be absorbed by clothing. The clothing acts like a wick, continuously drawing up the melted fat and feeding the fire.
So the clothing is like the wick, the melted fat is the fuel, and the body. Well, I guess that's the unfortunate candle.
It's a grim analogy, but it kind of makes sense.
It's a grim analogy.
Yeah.
But it makes sense.
It does.
But that still leaves us with a burning question.
Oh.
Pun intended.
Pun intended, I like it.
What could possibly trigger these fires in the first place if there's no external ignition source?
Well, that's where we get into the more speculative, but still grounded in science aspects of spontaneous human combustion.
Okay, now you've got me hooked.
Yeah.
What kind of internal reactions are we talking about? Could our bodies really be capable of generating that much heat?
To be clear, no known bodily processes can generate the kind of heat needed for spontaneous ignition.
Right.
However, the human body is a remarkably complex chemical system.
Yeah.
And there are metabolic reactions that do produce heat. Some rare conditions can even lead to elevated body temperatures.
So while these reactions wouldn't cause full-body combustion on their own, could they contribute to a fire if other factors, like the wick effect and the presence of flammable materials, are also at play?
That's a possibility that some researchers have explored.
Okay.
For instance, consider ketosis, the metabolic state behind the popular ketogenic diet.
Ah, the keto diet.
Yes.
Isn't that the one where you can eat bacon and cheese to your heart's content?
Well, maybe not that extreme.
Right.
But the key point is that during ketosis, the body shifts from burning carbohydrates for fuel to burning fat.
Okay.
And yes, this process does generate heat.
So some have theorized that under the right circumstances, the heat from ketosis could contribute to the ignition of a fire.
Potentially, yeah.
But wouldn't that mean anyone on a keto diet is at risk of spontaneous combustion?
That's a bit of an exaggeration. The amount of heat generated during ketosis is still far lower than what would be needed for spontaneous combustion.
Sure.
But it's an example of how even normal metabolic processes can produce heat.
Okay, so we're not saying keto diet equals fire hazard.
No.
But it is fascinating to think about these internal processes.
Yeah.
And how they might play a role in this phenomenon. What about other internal reactions? Are there any others that have caught the attention of researchers?
Well, there's the theory about a buildup of methane gas in the digestive system.
Okay.
Methane, as you know, is flammable.
So the idea is that this methane could potentially ignite under certain conditions.
Yeah.
Now, that would make for an explosive dinner party.
Again, this is a highly speculative theory.
Right.
While methane is indeed flammable, the amount produced in the digestive system is typically quite low.
Okay.
And is usually expelled, well, let's just say in a rather uneventful manner.
Yeah.
But the possibility, however remote, has led to some interesting discussions.
It seems like every time we debunk one myth about spontaneous human combustion, another one pops up.
They do, yeah.
So we've got fat, ketosis, methane. Are there any other internal reactions that researchers have considered?
There's also the role of static electricity. It's not a chemical reaction in the strictest sense. Right.
But it does involve the movement of electrons, which are very much a part of the chemical world.
Right, like when you shuffle across a carpet in your socks and then touch a doorknob, zap.
Think of a much milder version of that.
Okay.
The concept is that under certain conditions, the human body can build up a static charge.
Yeah.
While the static discharge is typically harmless.
Right.
Some theorize it could, in theory, provide the spark needed to ignite flammable materials.
Okay, so we're adding static electricity to our list of potential internal triggers. Now let's talk about our fifth and final factoid.
Okay.
The persistent myth that alcoholics are more likely to spontaneously combust because of high ethanol levels in their blood. Is there any truth to that?
That's a common misconception.
Yeah.
While ethanol is indeed flammable, the concentration in even a heavily intoxicated person's blood is far too low to ignite.
Okay.
Alcoholism has plenty of serious health risks, but spontaneous combustion is not one of them.
So we can officially debunk that myth.
I think so, yeah. Good to know. It seems like the key takeaway here is that while spontaneous human combustion, as it's often portrayed, might sound like something out of a science fiction novel, it's a phenomenon that can't be entirely dismissed.
Right.
There are plausible explanations for how the human body could act as fuel, how a fire could be sustained, and even potential internal triggers.
It's complicated.
It's a reminder that even in our modern age of scientific advancement, there are still mysteries out there.
Oh, definitely.
Burning, if you will, to be solved.
I see what you did there.
And as we continue to learn more about the complexities of the human body and the nature of fire, perhaps one day we'll have a definitive answer to the riddle of spontaneous human combustion.
Baby, yeah.
But even with what we know now, you have to admit there's something inherently intriguing about the idea of the human body harboring the potential for such intense self-destructive power.
Oh, absolutely. It taps into our deepest fears and fascinations with the unknown.
So while full-body spontaneous combustion might remain in the realm of fiction, the science behind it is surprisingly real and much more complex than you might imagine.
Exactly. And it's that complexity that makes this topic so fascinating to explore.
Well said. We've explored the fuel sources, the internal triggers, the wick effect, and even debunked some popular myths.
We did.
But what about the environment surrounding these fires? Could external factors play a role as well?
That's a great question, and it leads us to another crucial aspect of this phenomenon. Remember, even if we accept that the human body can act as fuel under the right conditions, we still need to consider the environment in which these fires occur.
Right, it's all about context.
Yeah.
So what kind of external factors are we talking about?
Well, one of the most significant factors is the presence of accelerants.
Accelerants, you mean like gasoline or lighter fluid, the things you see in arson cases?
Yes, but it's not always that dramatic.
Okay.
Accelerants can also be seemingly innocent substances that we encounter every day. For example, certain types of furniture stuffing, curtains, and even some clothing materials contain chemicals that can easily ignite and burn rapidly.
Wow, so something as ordinary as a sofa cushion could contribute to a fire.
Absolutely. And the presence of these accelerants can dramatically influence how quickly a fire spreads and how intense it becomes.
I'm starting to see how the pieces of this puzzle might fit together.
Yeah.
You've got the fuel source, the body fat, the wick effect, possible internal triggers, and now accelerants in the environment.
It's a complex interplay of factors that can lead to these unusual and often tragic events.
It makes you think about how these cases are often portrayed in the media.
Yeah.
The idea that someone just spontaneously combusts out of thin air is rarely, if ever, the whole story.
Exactly. It's crucial to look at the evidence objectively and consider all possible explanations.
Okay, accelerants check. What other external factors have researchers considered when investigating these cases?
There's the role of external heat sources. It might seem obvious, but it's an important factor to consider.
Right.
Remember, we're talking about cases where there's no clear evidence of an intentional external ignition source.
So no one is setting these people on fire intentionally.
Right.
Okay.
But there are other sources of heat that might not be immediately apparent. For example, a smoldering cigarette, a faulty electrical appliance,
right,
or even a space heater left too close to flammable materials.
So these fires could start externally, but the cause might be overlooked or misinterpreted.
It's a possibility.
Okay.
These heat sources might not be strong enough to ignite a person directly,
right,
but they could easily set nearby materials on fire, which could then spread to the victim.
It's a stark reminder that fire safety is crucial, even in seemingly ordinary situations.
Absolutely.
Yeah.
A small, unnoticed heat source can have devastating consequences.
Okay. External heat sources, accelerants.
Yeah.
Any other environmental factors we should be aware of?
Well, there's the less talked about but still very real possibility of something called the chimney effect.
Chimney effect. Like Santa Claus getting stuck.
Not quite Santa Claus, but the principle is similar. In some cases, the layout of a room or a building can create a sort of natural chimney, allowing a fire to draw in oxygen and intensify rapidly.
So the room itself becomes a giant fireplace.
Yeah.
That's a terrifying thought.
It's a phenomenon that firefighters are very familiar with.
Right.
Certain building designs can create updrafts and air currents that can make a fire spread much faster and burn hotter.
So even if a fire starts small,
right,
the way a room is structured could make it much more dangerous.
Exactly. It highlights the importance of understanding fire dynamics and how seemingly insignificant details can have a major impact.
Okay. I'm starting to see how spontaneous human combustion, as it's often depicted in fiction, is more about a perfect storm of unlikely circumstances than some mystical ability to burst into flames.
That's a very insightful way of putting it. It's not about magic or the supernatural, but rather about the interplay of complex chemical and physical processes.
So we've explored the fuel sources, the internal triggers, the wick effect, the environmental accelerants, the external heat sources, and now the chimney effect. It seems like we've covered just about everything there is to know about spontaneous human combustion.
Well, not quite everything.
Oh, come on. Don't leave me hanging. What else is there?
It's the role of the victim's health and lifestyle.
Okay.
Now, before you jump to conclusions, I'm not saying that these people did anything to cause these fires.
Of course, it's not about blame or judgment.
Exactly. But it is important to consider factors like age, mobility, and any pre-existing medical conditions that might have contributed to the circumstances surrounding the fire.
Okay, that makes sense. For example, if someone is elderly or physically impaired, they might have difficulty escaping a fire, even if it started small.
Precisely. And certain medical conditions like diabetes or circulatory problems can increase the risk of complications from burns.
So in some cases, the victim's health might explain why a fire had such devastating consequences, even if the initial cause wasn't directly related to their condition.
Right. It's about looking at the whole picture and understanding how various factors can converge to create a tragic outcome.
So to recap, we've explored the fuel sources, the internal triggers, the wick effect, the environmental accelerants, the external heat sources, the chimney effect, and now the victim's health and lifestyle. It's a lot to take in, but it's crucial to remember that each of these factors plays a role in understanding these unusual burning cases.
Yeah, it's amazing to think about how many different factors could play into what appears to be, on the surface, a single event.
Yeah.
It truly shows how complex these cases can be and why they've remained so mysterious for so long.
Exactly. And speaking of mystery,
there's
another layer to this phenomenon that we haven't touched on yet.
The historical and cultural perceptions of spontaneous human combustion.
Oh, you mean how people have explained these events throughout history? That sounds fascinating. Let's dive into that.
Well, Before modern science offered more rational explanations, people often attributed these strange burning cases to supernatural forces or divine intervention.
So we're talking about acts of God or even demonic possession. That takes us pretty far from the realm of chemistry.
It does.
Yeah.
But it's important to remember that for centuries, people lacked the scientific knowledge to understand phenomena like fire and human physiology.
Right.
Anything that couldn't be readily explained was often attributed to the supernatural.
Makes sense. Before we had science to help us understand the world, we relied on myths and legends to fill in the gaps.
Precisely. And spontaneous human combustion, with its seemingly inexplicable nature, was ripe for those kinds of interpretations.
Sure.
For example, some cultures viewed these burning cases as divine punishments or the work of evil spirits.
It's incredible how our understanding of the world shapes our perceptions, even when it comes to something as terrifying as spontaneous human combustion.
Absolutely. And as science progressed, and our understanding of fire and the human body grew, those supernatural explanations gradually faded, replaced by more evidence-based theories.
But I imagine that even today, with all our scientific knowledge, there is still a certain allure to the unexplained, a fascination with the mysteries that science hasn't fully unraveled.
Oh, absolutely. It's what keeps us curious, keeps us searching for answers. And who knows, maybe there are still some surprises in store when it comes to spontaneous human combustion. But for now, the most likely explanation lies in the complex interplay of factors we've discussed today. The human body as a potential fuel source, the wick effect, possible internal triggers, the presence of accelerants and external heat sources, the role of the environment, and even the victim's health and lifestyle.
It's like putting together a puzzle, isn't it?
It is.
Each piece contributes to the overall picture. And only by considering all of them can we hope to understand the full story.
You put it perfectly. It's not about magic or the supernatural, but about understanding the often hidden complexities of seemingly simple things like fire and the human body.
Right.
And that's what makes this topic so endlessly fascinating.
Well, that brings us to the end of our deep dive into the world of spontaneous human combustion.
It does.
We've debunked myths, explored theories, and delved into the fascinating chemistry that makes this phenomenon both terrifying and intriguing.
Absolutely.
Hopefully our listeners have come away with a new appreciation for the science behind fire.
I hope so.
And a healthy dose of skepticism.
Yes.
The next time they encounter a sensationalized story about someone bursting into flames, and perhaps even a spark of curiosity to learn more about the mysteries that still surround us. Remember, the world is full of wonder. And even in the most seemingly mundane things, there's often more than meets the eye. Until next time, stay curious.